Hello, friends. A magnet is such a part of our life that we see every day, but we hardly ever think deeply about where its energy actually comes from. Since childhood, we have been told that a magnet can pull objects like iron, it can turn a compass needle towards the north, or it can be used in motors and generators. But when we think about it more seriously, a question arises in our mind. How does a magnet remain a magnet forever? Why doesn't it run out like a battery? And what is the true source of the power it shows? Does this energy come from outside? Is it hidden inside the magnet? Or is it some other mystery that we need science to dive into? To understand magnets, we must go down into the world of atoms. Every substance is made of tiny atoms, and in every atom there is a nucleus with electrons constantly moving around it. These electrons are the real heroes of this story. They don't just orbit, they also have an intrinsic property called spin. Spin is not just ordinary rotation, but a quantum property. It is as if each electron carries a tiny magnet inside itself. Now imagine, if billions and trillions of these tiny magnets were scattered in random directions, then overall no magnetic effect would be seen. But if somehow they all line up in the same direction, then the whole material becomes a giant magnet. This is the hidden secret inside ferromagnetic materials like iron, cobalt, and nickel. In these special metals, the electrons show a kind of collective behavior. It is like an army of soldiers standing in a line. If every soldier stands wherever he likes, from outside you won't see any pattern. But when all soldiers march in one direction, you feel a powerful force. Similarly, when the spins of electrons in a ferromagnetic substance align, a magnetic field is created. Now the question is, where does this energy come from? Is a magnet constantly producing power, or is it stored energy? The truth is, a magnet does not spend any energy. It is magnetic only because of its internal structure. The magnetic field is simply the result of the spins and movements of electrons. It's not like the magnet is releasing energy all the time and will eventually run out. This state is stable as long as the internal arrangement of the material is not disturbed. To understand this more deeply, we need quantum mechanics. When two electrons are close to each other, they interact through a special effect called exchange interaction. This interaction decides whether the spins of electrons will stay aligned or go opposite. In ferromagnetic materials, this interaction forces them to stay aligned in one direction. That's why magnetism appears there. In other substances, this doesn't happen, which is why they are not magnetic. Now you may wonder, if a magnet does not consume energy, then where does the energy come from when it pulls something like an iron piece towards itself? The answer is fascinating. When a magnet attracts iron, it is actually the interaction between the magnet's field and the atoms of the iron. The domains inside the iron also get aligned under the influence of the magnet, and that process pulls the iron piece towards the magnet. The energy you see is not coming out of the magnet, but is the result of a change in the total energy balance of the system. To understand this, think in terms of potential energy. When the iron piece comes closer to the magnet, its potential energy decreases, and that decrease converts into kinetic energy, making the piece move towards the magnet. So the strength of a magnet is actually a gift of quantum-level phenomena. The spin of electrons, their movement, and the exchange interactions between them are the true sources of this energy. This is not an external force, but an intrinsic property of matter itself. That is why, unless the magnet is heated too much or given a strong shock, it stays magnetic. If heated, the alignment of the electrons breaks, and magnetism disappears. This point is called the Curie temperature. Let's compare it with a battery. A battery slowly spends its charge and eventually runs out. But a magnet does not do that. It does not spend any charge. It permanently shows magnetism because its energy is not brought in from outside, but comes from within its structure. This difference makes a magnet both mysterious and wonderful. If we look at nature, we'll see that magnetic fields are not limited to small magnets. The Earth itself acts like a giant magnet. Its magnetic field protects us from dangerous solar winds from space. The source of this is the molten iron in Earth's core, which is always moving. This motion creates a huge electromagnetic dynamo, which generates the Earth's magnetic field. This means magnetism is a fundamental part of nature, tied to both matter's depth and motion. Our modern technology also depends on this very power of magnets. Motors, generators, hard disks, speakers, all use magnetic effects. If magnets were spending energy all the time, none of this would be possible. But since it's a permanent property, we can use it endlessly. Here's another way to picture it. Imagine a pot of water. If the water is still, it looks like there is no energy. But inside, the water molecules still carry kinetic energy. Similarly, in the case of a magnet, even if nothing seems to happen outside, at the atomic level an incredible arrangement is working, creating the magnetic field. People often ask whether a magnet's strength can ever fade. The answer is yes, but not because it uses up energy. Instead, it fades if the arrangement is disturbed. For example, if you heat a magnet too much, it will lose its magnetism. If you drop it repeatedly or give it shocks, its alignment may also break. But under normal conditions, a magnet can remain strong for hundreds of years. The most fascinating part of this story is that a magnet's energy really comes from the fundamental quantum properties of matter. It makes us realize how amazingly the universe works. A small piece of metal with billions of electrons aligned can create such a huge force that it pulls iron towards it. And we use this power everywhere, from generating electricity to storing data. In simple words, we can say that the strength of a magnet is free, but behind this free power lies a deep scientific mystery. The collective behavior of electrons is nothing less than a miracle. It reminds us that even the simplest things in nature hide the deepest science within them. So the energy of a magnet does not come from outside. It comes from within its atoms. The spins of electrons and their quantum interactions create the magnetic field. This field does not constantly spin like a machine, but stays permanent as long as its internal structure remains intact. That is why a magnet is both mysterious and useful for us. If you enjoyed this video, don't forget to like, share, and subscribe. And do comment to let us know which topic you'd like us to cover next.